So I'm going to present the work we did this week in order to create maybe a new approach for the client, but for sure an approach for alternative clients that can request data live from a meeting using GraphQL. So I'm going to start. In terms of architecture, what we did is this is what Gustavo did, making BBB apps ACA to feed PostgreSQL database with chat messages, users, and meetings. And of course, later we will add more entities, but now that's what we achieved in a database modeled by Paul. So that's the events as they happen in the server. They are the BBB ACA apps is inserting and updating the data in PostgreSQL. And we used Hasura. That's a GraphQL server. And this server is codeless for schema, so we don't need to create the schema. Basically, whatever we create in the Postgres database, we can expose to a client. And this presentation is a little bit technical, but the nice thing about GraphQL is that the client can say how it wants to consume the data. So let's suppose, well, I'm doing a spoiler of the next slide, so let's continue. So the architecture is BBB ACA is feeding the Postgres database, and then Hasura is consuming data from this database and feeding the browsers with the live results of a query. So here I created a simple diagram showing how the GraphQL live query works. Basically, the browser makes a WebSocket connection to Hasura, and it says welcome. So the browser sends a GraphQL query. The first time Hasura queried Postgres, it do like a SQL query and get the results, and results are transmitted back to the browser. And after that, Hasura continues monitoring the database, and it do it like a pulling in the table. It keeps re-executing the query, which can be, of course, in memory if you make the proper tuning in the Postgres database. And whenever a new version of the data is available, it sends to the browser. So it's, let's suppose I have my Apple Watch running the system. The Apple Watch can make a GraphQL query, and it will not consume any traffic if there is no new information to be queried. So this is the basic flow without BigBlueButton participating. And in the yesterday's hackathon, I figured out how to integrate Hasura with BigBlueButton. So let's go to next page. The diagram gets a little bigger. But basically, when the WebSocket connection arrives through Hasura, it makes a webhook call to the BBB and says, okay, this user wants to connect. Should we allow? BBB says, yes, allow him to connect. And this is his meeting ID, his user ID. So Hasura is aware of the context of the user, which meeting it should get the data and things like that. So Hasura allows you to define this kind of collection level permissions, and it's pretty powerful. So basically, the same flow will happen, but with this in the middle, we ensure that the client will only see data for its own meeting. So the pieces for that are there. I just wanted to validate it, and it worked. About the scaling, I can see it scaling in several ways, and the simpler one is, okay, we can have this Postgres plus Hasura as a kind of node, and we can automatically scale it, and it will just go. We make the replication between the Postgres servers and Hasura. Each Hasura can query one Postgres, but there are other ways, like creating one cluster of Postgres and many Hasuras. It depends on where the bottleneck will be. So this is up to be discovered to see if we will scale it in pairs or individually. And then we can get several browsers. I think if we continue with this work, we will probably go like 10,000 users or something like that. So we put the architecture for our next level. That's why we are doing it. Okay, so the main difference from the current architecture is that with Meteor, the server decides what to send to the client. And client has no way to say, okay, I just want a subset of the fields available for the user. So if I want to get like the chat message, I will get everything that the server knows about the chat message. And the client has no way to say, no, I just want the count of the message on aggregation or something like that. So it's heavy. And also, in the current architecture, the client must keep track of all the data, so it consumes a lot of memory in the browser also. So with GraphQL, we get rid of this, and the servers offer a secure subset. It's a term that I just minded that will describe. That's basically when you connect, servers say, okay, you are a participant of this meeting and you are a moderator, so you can see this, or you are attendee, you can see this. But from this subset, the client can say, okay, I just want this field or the sum or the count of this field, things like that. So we give it to the client to decide what it wants to consume. So do you guys have any questions? Good. I prepared some questions to answer. So, can we do pagination? Yes, we can. We can from the client say, let's imagine we have the chat, and we want only to see the last 10 messages, and it's a page. And when you scroll up, we say, okay, I'm the previous page or things like that. The server will send you that page in a reactive way. So the client will only have the current data that it's showing. So it's going to be much lighter for the client. So thanks for the question. The next one is, can we do server-side aggregations, like a count of the users? Because now we show the number of users in the meeting, but for doing that count, we need to have the full list of users. So yeah, we can do server-side aggregation. So if I wanted to, well, if I had 1 or 2 more days, I would probably do something like showing the number of attendees in the clock, and I could, okay, 10 attendees, it's good, or you know, we can limitless what we can create with this, and it's going to be super fast and use almost no bandwidth for that. Yeah, the client will consume very little memory. So can we use for IoT in hybrid scenarios? Let's imagine an example of a light color below a tablet in front of a waiting room. We want to show it green when the room is empty, but red when the room there is someone in the room, and we want a Raspberry controlling that. We can have that. It's easy to do, or a tablet, things like that. So yeah, we can imagine some IoT devices integrated with BigBlueButton because of the low memory footprint. Did it work? Can we see a demo? Yeah. So let's go for the demo. Guilherme, do you join the meeting already? Okay, we will show you how to create this client in less than 1 minute. I know I was going to present, but well, we are short in time, so let's skip this part. No, it takes more than 1 minute actually. But the truth is that it's really simple. You just connect to GraphQL, and this is a super simple demo that we created. Let me show the full thing. I will just load it, get a join URL. it will make the, let me unfilter here. So it makes the join call, the API call, and then the GraphQL call. This is just a demo of a check authorization that the server does when you connect to the WebSocket. And here I want to show that, well, in BigBlueButton currently, even if you have the chat not visible in the screen, you are still getting the updates for the chat. And here we are demonstrating that we can click here, and when you click, the component is mounted and the query is activated from the client to the server. So we start receiving data for that particular collection. And I'm going to activate the both here. Can you send a message, please, in the chat, Guilherme? Hey. Let me open the meeting in this another tab. Can you send another one? Okay, a different one, please. Yeah. Test another one. So the client is reacting as when we send the message. Let me just move here. 1, 2, 3. So it's instantly updating the simpler client, and we also have a talking indicator. So can you mute yourself, Guilherme? It's automatically updating the user talking. And now I'm going to unmount the last chat message. Can you send another chat? Yeah, we're not getting the chat messages in the WebSocket. So it's really saving bandwidth. When you're not using the data, it's not consuming the data. Well, and that's it. So now, really, do you guys have any questions? I don't have other questions prepared. This is for real. Let's go on another. That's awesome, Diego. Okay, great.